questions 1 through 4 on the 2001 grade 12 Euclid math contest. What are the values of x such that 2x minus 3 all squared is equal to 9? All right, so we've got 2x minus 3 all squared is equal to 9. Take the square root of both sides and you'll get plus or minus 3. So 2x minus 3 is equal to 3, and 2x minus 3 is equal to minus 3. So the first one will give you 2x is equal to 6, x is therefore equal to 3. And the second one would give you 2x is equal to 0, so x is equal to 0. So x equals 3 and x equals 0 are your values of x. If f at x is equal to x squared minus 3x minus 5, what are the values of k such that f at k is equal to k? So f at x is equal to x squared minus 3x minus 5, and they want f at k equal to k. So f at k is going to be k squared minus 3k minus 5, and they are saying they want that set to k. All right? So putting the k on one side, you'd get minus 4k minus 5, like that. And does this factor? I believe so. k, 5, 1, minus 5, and plus 1. That would do it. And therefore k is equal to 5 and negative 1. So those are your values of k that make f at k equal to k. Determine all xy such that x squared plus y squared is equal to 25 and x minus y is equal to 1. So x squared plus y squared is equal to 25, and x minus y is equal to 1. So we can substitute one into the other, so whichever way you want to do this is fine. 1 minus y, like that, for x, and substitute that into this equation. So you'd get 1 minus y, 1 plus y squared is equal to 25, and therefore this is 1 plus 2y plus y squared is equal to 25. And therefore 1 plus 2y plus 2y squared is equal to 25. And now we can put everything on one side. So 2y squared plus 2y minus 24 is equal to 0. And then you can divide through by 2. Y squared plus y minus 12 equals 0. And then factor, and you get y, 3, and 4, positive, negative right there. And therefore y is equal to 3 or negative 4. And now we have to get the pairs, so we have to determine the x value, and we can easily do that using that formula. So if y is 3, x would be 1 plus 3, which is 4. So our first pair is 4, 3. And if y is negative 4, x would be 1 minus 4, which is negative 3. So our second pair is negative 3, negative 4. So these are our xy pairs that satisfy those two equations. 4, 3, and negative 3, negative 4. The vertex of the parabola y is equal to x minus b all squared plus b plus h has coordinates 2, 5. What is the value of h? So we have y is equal to x minus b all squared plus b plus h, like that. Now we know that a parabola has an equation of the form ax minus h squared plus k, where hk represents the vertex of the parabola. Okay, so for example, if you have a parabola like that. This is the vertex right here, and that point is HK. Okay? So in this formula, they've given you something that's similar, right? They've given you it in this form, and that's definitely helpful because that means that our vertex HK is of the form B plus H. It's exactly in that form right here. Now they've told you that this parabola has coordinates 2, 5. So 2, 5 is actually the vertex of the parabola. All right, great. It's right there, vertex of the parabola. Okay, so that makes it even simpler. So 2, 5 is HK. So that's B and B plus H. Well, that means B is equal to 2, and then 5 is equal to B plus H. So B plus H is equal to 5. So if B is 2, substitute that in there, and we get 2 plus H is equal to 5, and therefore H is equal to 3. And that is what they want us to figure out. What is the value of H? In the isosceles triangle ABC, AB is equal to AC, BAC is equal to 40. Point P is on AC such that BP is the bisector of ABC. Similarly, Q is on AB such that CQ bisects ACB. What is the size of angle APB? So let's blow this up a bit. All right, so let's start labeling this. BAC is 40, so this angle is 40. Point P is on AC, so it's right here, such that BP is the bisector of angle ABC. So ABC is this angle, and BC cuts that angle in half. So I'll call this X, and I'll call this X. And then, what else do they tell you? Q is on AB, such that CQ bisects ACB. So similarly, that is the angle of ACB, and QC cuts that in half. So if that's Y, that's Y. And they want you to figure out the size of APB. APB, so they want this angle. We'll call that Z. Now one thing I immediately noticed is that AB is equal to AC. This is the same as that. So that means that's isosceles. If that's isosceles, then that means that this angle is the same as that angle. So if that is X and X, this is also X and X, like that. So we can calculate X immediately. We have 4X plus 40 is equal to 180 if you take the sum of the angles of that triangle. Correct? So that means that 4x is equal to 140, and therefore x is equal to 35. So this x is equal to 35, like that. And now if we want to calculate z, we can use this triangle right here and the sum of the angles of that triangle. So it would be 35 plus 40 plus z is equal to 180, and therefore z is equal to 180 minus 75, and therefore z is equal to 105. That's the angle APB. So angle APB. And now part C. In the diagram, AB is equal to 300, and PQ is equal to 20, and QR is 100. Also, QR is parallel to AC. Determine the length of BC to the nearest integer. So let's start labeling this. AB is from here all the way there, and they're saying that's 300. Okay, so 300, that whole thing. PQ is this small area, and that's 20. And then QR is that side, and that's 100. All right? And QR is parallel to AC, like that. And they want you to figure out BC right here. Okay? So let's see, what can we label. This angle, these are parallel, so that means that if you drew a Z pattern like this, that would make this angle the same as that angle. Okay? So I'll put an x in there to denote that angle, and therefore that is also x, the angles. And both of these triangles have 90 degrees there, and therefore the third angle of both triangles must be the same. If that's y, that must be y, because the other two are the same. So if you subtract from 180, it would be the same value. And therefore these two triangles are similar triangles. This one, the small one, and the big one right there, this whole thing right there. Those are similar triangles. So using similar triangles, we can figure out a relationship. And we probably are going to need the hypotenuse, this one right here, that hypotenuse, and we can easily figure that out using Pythagoras. So it would be 20 squared plus 100 squared is equal to h squared, h for hypotenuse. So we have 400 plus 10,000 is equal to h squared, and therefore h is 10,400 all under the square root sign. All right, so now let's use similar triangles. BC, that side, over the hypotenuse of the entire triangle, the big one, so we know that's AB, is equal to, in the small triangle, the side that is y and the right angle, which is what? 20. It's QP. So I'll just write QP for now, so you know which side I'm referring to, and over the hypotenuse. So the hypotenuse of the small triangle is PR. So using similar triangles, we get this relationship. So BC is what we're trying to figure out. AB, they give you in the question, is 300. QP, they also tell you, is 20. And PR is the hypotenuse of that small triangle, which we determined to be the square root of 10,400. And you just now solve for BC. So BC would be 20 times 300 all over the square root of 10,400, like that. And if you do this, you get 58.8 approximately. And they want the length to the nearest integer. So to the nearest integer, it would be 59. In an increasing sequence of numbers with an odd number of terms, the difference between any two consecutive terms is a constant d, and the middle term is 302. When the last four terms are removed from the sequence, the middle term of the resulting sequence is 296. What is the value of d? Okay, so we have a sequence where the difference between any two consecutive terms is a constant d. So if this is the first term, a, the next term will be a plus d, the next term will be a plus 2d, and so on, a plus 3d, like that. So this is the first term, this is the second term, third term, and we're going to go all the way up to the kth term, okay? And the kth term will be a plus k minus 1d, right? Because look at the coefficient of the d, it's always one less than the term number. Now, what we are interested in is the middle term. We want this middle term right here. But how do we figure that out in terms of k? Well, they tell you that there's an odd number of terms, so k is odd. And if there's an odd number of terms, then the middle term will be k plus 1 divided by 2, that number. Now, if you're not convinced of that, you think, well, how am I supposed to know that? Well, just think about it. If k is odd, let k equal, say, 11, right? If you have 11 terms, what's the middle term? It's 6, right? It's the sixth term. You can easily figure that out in your head, or you can just write down 11 terms and pick the middle term. Mathematically, it's 11 plus 1 divided by 2, which is 6. And that's how I figured out k plus 1 over 2. So if this is the first term, this is the second term, this is the third term, the middle term is k plus 1 over 2. Okay? In terms of the term number, not the value of the term. The value of the term will be a plus k plus 1 over 2 minus 1. Remember, you have to subtract 1, d. Okay? And then if you do the math here, this becomes a plus k minus 1 over 2d. And there you have, this is your middle term. And they have told you that it is 302, like that. So that's our first equation. All right? There you go. Now we move forward to the second equation, or the second scenario, which is very similar. When the last 4 terms are removed from the sequence, the middle term of the resulting sequence is 296. So now they have a scenario where they've removed the last 4 terms. So now you have k minus 4 terms. And similarly, we have the same kind of terms in terms of the first one, second one, third one, but the middle term is not going to be this one anymore. It's going to be different. And we have to figure out which term number is it. So in a very similar way, the middle term is going to be k minus 4 plus 1 all over 2, which is k minus 3 over 2. That's the middle term in this scenario. So k minus 3 over 2. And now we want the value of the term in terms of a and d. This was a plus d. The third term was a plus 2d. The last was a plus k minus 5d. So what about the middle term here? Well, it would be similar. A plus k minus 3 over 2 minus 1d. And if you do the math, you'll get a plus k minus 5 over 2d. And they tell you that this is 296. So this is equal to 296. And that is your second equation. So we have to use these two equations to solve for d. All right? So we've got, what are the two equations here? We've got a plus k minus 1d, k minus 1 over 2 is 302. And our second equation is a plus k minus 5 over 2d is equal to 296. All right. So we'll use these two equations to try to find d, which is what they're asking for. This I'll call equation 1, this I'll call equation 2. So I'll just do 1 minus 2. That should be able to get rid of the a's. So 1 minus 2 on the right side is pretty straightforward, 302 minus 296. On the left side, it will be a plus k minus 1 over 2d minus, from 2a minus k minus 5 over 2d, right? And the a's do indeed cancel, so we get left with k minus 1 over 2d minus k minus 5 over 2d, and then this looks like 6. Okay, factor out the d so we can do the algebra in the middle. K minus 1 over 2 minus k minus 5 over 2, like that. So this looks like k minus 1 minus k plus 5 all over 2 is 6. And this looks like the k's cancel. Great. So 5 minus 1 is 4. 4 over 2 is 2. So 2d is equal to 6, and therefore d is equal to 3. There you go. That is what they wanted in the question. Calculate what is the value of d. So we got d to be 3 right here. There are two increasing sequences of 5 consecutive integers, each of which have the property that the sum of the squares of the first 3 integers in the sequence equals the sum of the squares of the last 2. Determine these 2 sequences. Okay, so you have first and foremost 5 consecutive integers, n plus 1, n plus 2, n plus 3, and n plus 4. These are 5 consecutive integers. And they have this property that the sum of the squares of the first 3 integers, so n squared plus n plus 1 squared plus n plus 2 squared, is equal to the sum of the squares of the last 2. So that would be n plus 3 squared plus n plus 4 squared. All right? So that is our fundamental equation. So we can just expand and solve. So n squared plus 2n plus 1 plus n squared plus 4n plus 4 is equal to n squared plus 6n plus 9 plus n squared plus 8n plus 16. All right. This n and this n and this n, I'm trying to see, okay, we got 3n and 2n, so that will become n squared. 2n, 4n, that is 6n, and then 5, and then this looks like 6 and 8 is 14n, 9 and 16, 25. All right. So n squared, 6 minus 14 minus 8n, 5 minus 25 minus 20. All right. Can this factor? Maybe. Let's see here. n, 10 and 2 minus plus. There you go. So that means n is either 10 or n is negative 2. So remember, these were our consecutive integers. So if n is 10, our list becomes 10, 11, 12, 13, 14, like that. That is our first list. Or what do they call, what is the term? Sequences. Okay, that's fine. Sequence, list, whatever. If n is minus 2, our sequence becomes minus 2. You're adding 1, so minus 1, 0, 1, and 2, like that. So these are our 2 sequences. If f at t is equal to sine of pi t minus pi over 2, what is the smallest positive value of t at which f at t attains its minimum value? All right, so we have f at t is equal to sine of pi t minus pi over 2, like that. Now pi is referring to 180 degrees, so I'll put that in there. Sine is 180 degrees, t minus 90, 180 divided by 2 basically. And therefore this becomes the sine of 90 2t minus 1. And remember that t is a positive value. T is positive. So let's make a table and let's see what we get. So we've got t, 2t minus 1, and the value of f at t, which is of course sine of 90 2t minus 1, like that. And let's see what values we get. Now, t is 0, right? But I'm going to start, t is a positive value. So it has to be greater than 0. So even though t is not possible to be 0, I will start with 0 just to illustrate how that is not going to be possible. We have to find something else. So if t is 0, this is negative 1, and therefore this becomes the sine of negative 90, which is negative 1. All right? Now, t is positive, so this is not allowed, but this is sort of where we're beginning. Everything is going to be greater than this boundary. So let's start with whatever you want to start with, 1. That sounds pretty good. So that means 2t minus 1 is 2 times 1, which is 2, minus 1 is 1. And therefore we now have the sine of 90, and the sine of 90 is equal to 1. Let's keep going. T is 2. We have 2t minus 1 is 2 times 2, which is 4, minus 1 is 3. And therefore this becomes the sine of 270, which is equal to negative 1. And let's go to 3. This gives 5, and this gives the sine of 450, and the sine of 450 is equal to 1. And I'll do one more. T is 4, then 2t minus 1 is 7, therefore this becomes the sine of 630, which is negative 1. So as you can see, it goes back and forth between 1 and negative 1. So the value of f at t attains a minimum when f at t is negative 1. So these guys right here. The minimum value of f at t is negative 1. You can't go any lower than that. And when does that happen? Well, it happens when t is equal to 2, when t is equal to 4, and so on. And they want the smallest possible value of t. So in our table, even if we kept going, our smallest possible value of t that would make f at t minimum is t equal to 2. In the diagram, ABF is equal to 41, CBF is 59, DE is parallel to BF, and EF is 25. If AE equals EC, determine the length of AE to 2 decimal places. Okay, so we've got this diagram, and it's pretty straightforward here. We can label what we need. We can call A to F x, this distance right here. And we know that AE is equal to EC. A to E is the same as E to C. So since A to E looks like x plus 25, E to C is also going to be x plus 25, like that. Okay? Now we have to use two relationships between the angle and the sides using trigonometry. So the first triangle is this one right here. And with that, using tan, I get the tan of 41 is equal to, if you remember, opposite over adjacent. All right? And then the next triangle that I'm going to use is this one right here. BCF, that one in there. And in that one, you'll get the tan of 59 is equal to opposite, which is, be careful, 25 plus x plus 25 all over BF. All right? So in the first one, you get BF is equal to x over tan 41. And in the second one, you get BF is equal to 50 plus x all over 1059. And therefore, since you have two possible values for BF, you'll set them equal to each other. So that means x over 1041 is equal to 50 plus x all over 1059. And this now, so this becomes x over 1041, which is 0.8692 to 4 decimal places. And this part is 50 over x over the tan of 59, which is 1.6642. Cross multiply and you'll get 1.6642x is equal to 50 times 0.8692 plus 0.8692x. If you bring the x's over to one side, you'll get 0.795x, and 50 times 0.8692 is 43.46. And therefore, if you solve for x, you'll get 54.67. And remember, they want you to solve for AE. AE is from here all the way down to there. So x plus that 25. So don't forget to remember that. So AE would be x plus 25. So therefore that would be 79.67, approximately, to 2 decimal places.